Welcome to Carlton's Math Corner. Today we are going to talk about the distributive property. At this time, please make sure you have your math journal, your vocabulary packet, as well as something to write with. Our target today is I can use the distributive property to simplify and evaluate expressions. Now, in a prior video, we learned that the distributive property means to introduce a number or a variable to a group of numbers or variables. And so here's an example. Scooby-Doo introduced himself to SpongeBob, Lucy, Robin, and Frozone, and they became friends, similar to as the 2 was introduced to the 3, and it's introduced to the 5. Now, in mathematics, when we have a number that's next to parentheses, that means that we multiply. And so we do 2 times 3, and then we do 2 times 5. And because there's an addition sign within the parentheses, then that means that there will be an addition sign in our expression. And so we have 2 times 3 plus 2 times 5. And so a distributive property means that we took that 2 and introduced it to our group. Now, if we evaluate this, 2 times 3 is 6, 2 times 5 is 10, add them together and then we get 16. Now let's look at another expression. So here's another example, and notice this one has a 3 on the outside, and then within the parentheses there's an x plus an 8. What steps do you notice that were taken? Well, what I notice is that the 3 was introduced, just like the previous problem. It was introduced to the x, and then it was introduced to the 8. And so that's what this is shown, that 3 times x and 3 times 8. But what I notice is that the 3x really didn't change. And that's what's different. It's because we don't know that the value of x is. And so with that said, we really can't solve any further than 3 times x plus, we can do the 3 times 8, which is 24. And so looking at this, really this is our expression in simplest form. We can't go any further. Let's look at another problem. How would we do something like this? We have 3 on the outside, then we have 2m minus 2. Well, same as before, introduce the 3 to the 2m, and then there's a minus in between them, and so I'm going to put that down, and then there's a 3 times 2. Basically what this is that the 3 is next to the 2. It's next to parentheses, it just means times. But notice the 2 is next to the m. That also means times. So really this is just 3 times 2 times m. So 3 times 2 is 6. And then 6 times m is just 6m. And then if we simplify this side, 3 times 2 again is 6. And so this is our expression in simplest form. What about number 2? Well, if we introduce the negative 8, so we put negative 8 times negative 3, there's an addition sign this time, and then we got to introduce the negative 8 to the 2n. So negative 8 times 2n. So let's look at the first expression. We have negative 8 times negative 3. Remember, a negative times a negative is positive, so 3 times 8 is 24, plus, and remember this is negative 8 times 2 times n. So negative 8 times 2 is negative 16. We don't have enough negatives to make it positive. And then times n, it just remains as times n, because we don't know that value yet. And so this is in simplest form. Our last problem, this is a little tricky one, because if you look on the outside, do we even know what number that is? All I see is a negative symbol. what is the only number that we can multiply something by that doesn't change its value? Because right now we're multiplying by something that hasn't changed the 4 or hasn't changed the 3. You guessed it right. It's a 1. 1 is the only thing that changes. So really on the outside of this, it's not a positive 1 because there's a negative symbol there. So really it's -1 times -4 plus -3r. So let's introduce the -1 to the -4. And then we put addition in the middle because that's what we see in our within the parentheses. And then let's introduce the -1 to the -3r. So same as before, a negative times a negative is positive. So 1 times 4 is 4 plus -1 times -3 times r. So -1 times -3 is +3. And then times r is just r. Nice job. So really what we're doing is we're introducing the number on the outside to the numbers, or sometimes variables, on the inside using multiplication. And then we place a subtraction or addition symbol in the middle of the two terms. Now, when I say terms, whoops, let's go back. When I say terms, what that means is I'm just looking at the numbers and or variables. And sometimes there's a number next to a variable. So right here, the terms that are highlighted are 3x, 3, 2x, and then 5. And so there are actually 4 terms in this expression. And the reason why we're talking about terms is because sometimes we can put our terms together. For instance, do you notice that this x and this x, so these two terms, are similar because they share an x. And I actually can put them together. And the way that I put them together is I start with the first number, I look what's in front of it. Well, it's just there's nothing in front of it, so it's a +3. So I have 3x, and then I look what's in front of the 2x. And I notice there's a minus sign. So I actually am going to keep the minus sign in front of that 2x. And so that means that I need to subtract these two terms to simplify them. And so 3 minus 2 is 1, and then we keep the x. Okay? Now the green, those terms are also like terms because they don't have a variable. They're just regular numbers. And we can always put together any numbers. And so notice what's in front of the 3 is just a +3 or +3. So we're going to keep that the way it is. And then look what's in front of the 5, a +5. So when we put them together is 8. And so the way that this expression now looks is not just, 1x and then 8. We have to put them together. So we do 1x plus 8. Why do you think I put a plus there? Yeah, basically because we combine them and the 8 is positive. So I can keep it as addition because addition shows me that the 8 is positive. Okay, and so if you want to get this in your notes, like terms basically means that they have to have the same variable, just like this 3x and 2x, and then they have to have the same exponent. Now, it looks like none of these have an exponent, but can you tell me what can I take any number to the power of which wouldn't change it? It wouldn't change its value. You're correct. To the power of 1. So I can take 5 and I can put it to the power of 1 and I still would get 5 because 1 5 is still equal to 5. And so all of these are to the power of 1, even though you can't see that exponent. Okay, so let's use this knowledge about terms and about like terms to look at a problem that has distributive property in it. Okay, so here is our new problem. Notice that there is a number on the outside of the parentheses, and then we have terms inside the parentheses as well as outside of the parentheses. What steps do you notice? How did I get these numbers? Because I notice up here I don't have a 10 and I don't have an 8. So where did those numbers come from? Yeah, you're absolutely right. Since there's a number next to parentheses, then that means that we need to use the distributive property and introduce that number to the other terms. So we're going to take 2 times 5x squared. Now remember, that's just 2 times 5 times x squared. So 2 times 5 is 10, and then times x squared, we just put it right next to each other, or right next to it, because we don't know what the value is of x. And then we introduce the 2 to the 4. So 2 times 4 times x is 8x. And then the addition kind of just follows with the new expression. And so we have 10x squared plus 8x. And then it looks like these terms are just copied down. Now, what's the next step that you observe? Exactly. We are going to look for any like terms. So I'm going to take a highlighter and I'm going to look for things that have the same variable and the same exponent. And this is x to the second power, and I notice there's no other term that is x squared. And so there are no like terms for that one. But I notice this one's just x, and remember everything is to the first power. So this is x to the first power. I notice this is also x to the first power. So these two are like terms, and I can put them together. And remember, the way that we put them together is we look what's in front of it. Well, this is kind of like a positive 8, so we put 8. And over here, it's a positive 4. So we are just adding them together, 8 plus a 4. And notice we had 12. And the x just remains with that expression, or with that term. And so 10x squared, there is nothing to add or subtract to it, and so that term remains the same. 12x is our new term, and the minus 4 is our last term, and notice nothing goes with that as well. All of these have different exponents as well as different variables. Okay, so when I get to that point, then that means that my answer is in simplest form. Okay, so this is in simplest form. So I want you to notice that I wrote the exponent, or the terms, based on their exponents. The greatest goes first, so x squared. Then the next one, the next least, would be x to the first, and then x to the 0 power. So please make sure that you write your answers out like this. Okay, I would like for you to try these problems at home for tomorrow. These are your ticket problems, and let me show you all of them. So I want you to rewrite these problems using the distributive property and then simplify them, and then combine any like terms so that your answer is in simplest form. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.